It's definitely gonna lead into the heart.
Wow.
It looks good. Look at the definition of the camera. Such a high quality camera. Oh my god. Oh, just tweet it.
Yeah,
If you just tweet it, it'll be in my page anyway. I don't need to upload it.
You have a live Google feed.
yeah, this is what I see. This is like a 20-second delay. That's uploaded to YouTube.
But yeah, if you just tweet it, actually don't send it to me. Just tweet it, it'll come in my page anyway. 'Cause I follow
27
our,
Oh, okay, yeah.
yeah, I follow our Twitter, so we just tweet it.
Okay, yeah. That's what it is.
That's the point. Our Twitter.
Oh, what? Who's that?
What? You see the
Someone
hand?
put the hand. Yeah.
Aha! I didn't see it.
How do I close it?
Adjust it or? Want me to adjust it?
Yeah, sure.
I mean, I don't know.
That looks pretty good.
How do I full screen this?
It's just not.
It's pretty good.
Is it good?
Yeah, I was right there.
That's cool.
That's good?
Yeah, I like that.
Oh, nice.
Get the little sensors too.
It looks so pretty.
I'm at 100%.
She's smiling.
What?
I'm just happy.
No, I know, it's just funny. It's because it's unexpected.
Jeez. Never smile.
You really don't.
Or you can do what I said.
We need two of them. We still
Put
have
out full posters. This. Okay, so, for example, if you want to do query the new values.
Oh, wait, this is.
Yeah.
Okay.
Should we just try
That's fine.
You know it's real.
You made a Twitter account?
You don't want to save them.
I'm not, you want to go about that? And I have the combination towards me. I have to spend that last week. No, I'm not the one thinking. I'll be like. Yeah, because there's that is after. Like there's blue girls, and then there's like it's for 2 hours. I recorded this happening. So I didn't get to see you performing I know, that's cool. I wasn't there. But then okay.
I'm gonna turn this spigot a little bit.
Yeah, the question's wrong.
This is the light.
Yeah.
Oh yeah, we gotta take pictures of that.
That's better actually.
Did you tweet it to others? I don't see it. And so why don't I see it?
That's just for one volume.
Maybe it's not complete. I see this one.
Maybe it takes a while. I definitely created it.
Maybe it's like not completely in real time. No,
Step back for a
Oh
second.
my god, did that one fall through or something?
Yeah, I just fell.
it just fell.
All right,
Yeah,
let's
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 Oh no.
let's fix them.
Let's fix them.
Motivation.
Do you want to?
Motivation. Okay. How are you? Good. We're a little bit early, but I'm so curious about
Okay, well this is an aeroponic system where we're controlling everything. So this actually goes inside. That's what we use to water.
I'll show you what the.
They're without soil, they're suspended in a medium, and you see that goes off. And this goes off at like regulated times depending on how much water your plant needs. We have a temperature sensor there, a photo sensor there, and we also have humidity sensor. Okay. Yeah, so that's the cyber part. But aeroponic gardening saves up to 70 to 90% water.
Over regular or over hydroponic?
Over in soil.
What do they lose when they don't have soil in terms of nutrients? There must be something.
Where they lose if they don't have soil.
Yeah.
Right. Actually, so we with the water in the bottom is actually a solution. So you can add like a regular ash or something. You can get your nitrogen and potassium and all that.
It's not just water.
Mix it right in.
This is how this goes under there, and this is how they control it. There's no soil. And the nutrients that it normally would get from soil, they put in
It's just dissolved.
It's dissolved.
So and it's a self-feeding system, so it goes back right back into the ground. And ideally you'll have to replace it every time.
Yeah. Oh my goodness.
But yeah, it goes if you can see that. This licks up.
Do you think the tomatoes would be as tasty? I don't know.
They're supposed to taste as good, and if you use organic solution, it's all organic.
That's true. Yeah. It's easier to control without soil. Because
Exactly.
soil is such a big thing.
It directly takes it up because it's mixed with
You're not handing out tasting.
We're not handing out tasting based on we thought about it for a long time. Yeah.
Because right now, we're not sure if that's plastic or not. That's very cool. That's very cool. And then easily adaptable, but you can change if you see something else that the plant needs, you can easily change this.
Yeah, you can easily change how often it's going on. You can turn the light on. And eventually you want to incorporate like a fan. It's open right now.
And it could also be a very large system.
Industrial, this is already being like researched by like large companies. I think GE has their own project and their industrial. But this way, this is for indoor urban farms, in large cities where you don't have
Exactly.
Yeah,
Exactly. Or also
There's
places.
yeah, this is all year round.
Which is a really nice thing. Yeah. Wow. It's really neat. Very cool.
Yeah.
Yeah, very nice.
Fix it or should we?
Oh yeah.
Oh, I was covering the light.
Should we just lift this up and fix the plant, or can you go through the top? Oh yeah, it's perfect. You can take that whole thing out. Actually.
This is like the number that's
Cover it. You might need another piece of.
So our system right here, I don't know you guys just know that. It's our plants are suspended. This actually goes inside. So when this mists up, this hits up. So directly the water goes into the right.
What's the concept? What source of Lansing has accessible?
We've tried out lettuce, and this is our vegan. You have to be like large
But like you really
and how we've been able to run our system as long as
How does this compare to your commercial system?
they don't necessarily have all the different it's the optimization we have where we have for example, how much water that this is how much water is needed. And also we're going to refill your water. So our system tracks and to create a very
I'm interested, I'm gonna develop one of these.
Okay. Have you tried anyone before? Or?
No, I mean, I didn't really know.
When I
Yeah, we're using there's a small
Do you have an image?
I can hear you. Actually, just hear
So yeah, so I can plug this in to show you a quick demo actually. So we just have a pump here, and right now it's just going 20 seconds on, 20 seconds off. But this is ideally regulated, you know, every 15 minutes or every hour. However much the
Pump, what is the pump power and how much volume are you?
so the pump actually just runs off of 12 volts. So it's relatively low power, but I mean with the small area of the spigots, you get enough of a spray. So what runs through here is 100 milliliters varying at a time. We expect, you know, a small fraction of that to actually be absorbed into the roots each spray.
Purified water or what kind of water? Is it mineral rich or?
So yeah, we actually we use the start with clean water, but mix in a nutrient solution. So where it would usually get its nutrients from soil, we add in the nitrogen and potassium and other
and this
critical.
is the material that we use for the roots.
What
This
is
is
that?
material. It's some sort of wool that we got at a hydroponic store, but you can put the seedlings directly in here. So we actually transferred this from the soil, but
Interesting, like this, what is exactly what it's. So this is the result of how much time? How much time?
this one we actually just transplanted. We had lettuce up here for about a week. So this one we transplanted yesterday.
So have you grown anything from seed?
Not from seedling. We haven't had our system running long enough to grow from seedling.
That's
Yeah.
Yeah,
That's really that's why yeah.
These are transplants. Okay,
Yeah.
well, these are amazing. These are really good plants. You guys made it. Okay, for a fair, I guess.
That's the point. Make it look nice for the
Yeah,
presentation.
let's see what this, all this stuff is.
I'm gonna film.
Okay. Put it on the light field.
Just 3 now.
It's just
So this is, do you guys have a card? Something written?
I'm sorry.
Do you have
Oh,
something
that's we don't
written I can
have.
take with me?
Oh no, we don't. I'm so sorry. But you can follow us on Twitter.
Have a picture of it with
What is she?
we have like a card, business cards to go with my follow us on. We can be.
I told her to follow us.
That's what I was thinking this morning. Like, shit, we should have business cards or something.
This group.
Which one?
Those are running outside the shower use.
What did she say it was? Wait, what did she say it was?
Pretty sure.
What?
You look at
There's a controversy. But she said the water, California Water Department.
We'll say like 50 to 70.
Yeah, but I've seen some.
I feel like compared to like the home use, you know, for like a home garden.
I think that's number includes
That's all you got. That's all.
includes cows as well.
All I know is that the hardware works pretty well.
Hardware's on point.
Should we offer for people to try?
The basil? We have rest of the basil in the bag. It's big, bro. It's so much food.
I just tried that.
We should find it. Is it still streaming?
All right.
Is it off?
It's just plugging in and out.
Oh, okay. You just plugged it. I was looking at the you don't run into
Saw how she went straight to the.
No, she's like very into it. She like wanted to grow, make her own business.
Damn, she is.
You guys
Yes, but it's just
go. I keep bumping into this thing. I'm gonna stay. Go. What is it called? Go block. Grow block.
he said it was organic and something.
It's just an organic medium.
Some
So it's like
material.
organic wool medium.
Just an organic.
That's what I said. She's like, I'm gonna know the exact. That's what I told her.
I can show you the bag.
Oh, that's true. We can look at that. Maybe it doesn't matter. I guess.
That's for the CO2.
Damn, these lettuces look really good.
Basil.
Basil.
That's basil.
Oh, wow. So you switched out the plants.
Okay, but lettuce, basil, and mint are all very similar.
They look strangely alive. Wow, these are really good from yesterday. Discrepancies here. Oh, is this dress? No, this is where's the salad here?
Oh,
It's like you have to give this to your plants and then it'll grow. Just so that if people ask, oh, what do you have in your
Product placement here.
There you go. That's for you. All for you. Aww.
Can you tell me? Can you present something to me?
Wow.
This looks pretty decent.
Any questions?
I don't know anything about this. Why don't you give me a short overview? What is this? You know what this looks like? Wait, it's true, you made this whole thing? You guys made this?
I made it on some.
Yeah, what is that?
It's a program.
This is the whole and visit our website, intrumescara.com.
Arduino.
I was wondering if you put like a URL for that. I got this thing. Okay, so I'm gonna read anything. Please, no, read it.
There will be a good amount of
Yeah, read this. This is the whole hour. What is plants and
So it's suspended.
I read it in air.
I mean, we
Essentially,
use this
yeah.
as a
We just collect the roots.
but it's not spoiled. The nutrients are all.
So this irrigation system is supposed to be inside the rocks.
And it spritz us through. It's not on here. I can turn it on actually.
Yeah, totally. It basically just spits the roots.
I am surprised you guys managed to pull this shit together.
And why this is so water?
would be
Yeah. Why this is so water efficient is because the excess is simply just recycled back into the reservoir.
And it also
No,
just
what is
really
the reservoir? Oh,
That's the reservoir.
Shut up. The box is the reservoir. Wait, this is awesome, guys. You guys get a group.
186. All right, thank you for your attention. Welcome to the CE 186 Final Project Symposium at the Jacobs Winter Showcase. It's a pleasure to have you. Thank you to all the students for all your efforts in making this possible. Thank you to all the visitors you all supported in various ways. Please tell the students how you support it so that they understand. So actually, in combination with the showcase, it's actually also their final. So they've been working hard to prepare a little spiel. There's a set of judges that will go around. Feel free to ask them for that spiel. And that's it. I really hope you enjoy the showcase. Thank you very much. By the way, my name is Professor Scott Moore. This is a course offered in Civil Environmental Engineering.
Okay, fine. Wait. We need to take a picture of you guys. Here. No, I'm not gonna take one with them. Why would I?
Not even part of
Wait,
it.
you're covering your plant.
Oh, chew on one side.
I don't want to be in it. Squish. More.
Switch? Oh, squish. You want to come in here?
okay.
I might be blocking.
It's over anyways.
All right.
Let's go see other people.
Sweet. That'll be a good demo.
Yeah, that's what I did.
Is this the live feed?
This is the live feed.
How do I get into the live feed?
You
Where's the
can't get
camera?
it. It's in there.
Oh, I see it. The camera.
Oh my god. Look
How are you 3 people, Peter? Oh, wait, you got 3 people to come. This is and choose 3 people.
That's true. Peter, these are my 3 people. Where are your people?
They're on their way.
I got 3 people.
They're on their way.
Are you
Just
sure
wait.
you got them?
My tally's at 2. Just wait. 5 o'clock is when we count down. So
Yeah, it's basically.
You want to take a quick walk? It's Python here. I came
The
from
Python's right there. They did.
Python?
They also have. Yeah. Would you like to see it go off? Oh wait, no, we gotta wait.
So Rudy is there and this.
Yeah, this sits inside the box, and then it goes right to the roots.
And this actually saves a lot of water because it directly hits the roots, and then the excess is simply recycled.
Instead of being evaporated or lost in the soil.
So you
There.
keep on recycling.
Yeah.
Yeah.
And what kind of nutrient is it? Just
This is the one we have for right now.
It's actually being grown without soil. So instead, the plant is sitting in just this woolly material. All the nutrients that the plant would normally get from the soil is supplied.
So I mean, if it's grown this way, what is about the concern about the organic? I mean, feeding this.
So it's whatever nutrients are in here actually. So if the
Yeah.
solution is organic, then it's just as healthy as any organic plant. Yeah, it's interesting. Thank you.
do you think we should like kind of people who come around just give our presentation,
Yeah.
kind of
Yeah.
practice? Yeah.
That's good.
Get a couple rounds in.
Yeah.
There's so many people.
And there's free cover.
I think it's because like our class is really busy.
Yeah, so one of our motivations to creating this project was to help itself and the agricultural sector of the state. And so while traditional farming techniques are very water intensive, we thought that we should apply indoor farming instead, which saves up to 70%. And so we created something called an aeroponic system that basically means a plant grown without soil. And so the plant, yeah, without soil. So the plant instead is being fed through this little. So the roots are in this enclosed dark box where this irrigation system is, and then the plants are exposed to light. And so we're really stimulating the optimal conditions for growing the plant. And there are many advantages to this, but the primary
Right. So the hardware works a little bit like this. We kind of have just our pump that runs the water through and spritzes through our different spigots, and then naturally whatever's not absorbed into the roots just falls back and is recycled. So then other than that, our Arduino controls light, turning it on and off. And so we have different sensors on the board and sensors in here to control the different levels, how much water, how much light it's going to be given. And that's about it.
And the information from our sensors is communicated wirelessly. And within that, we like optimize like graphs. For example, you can see right here. You can tell how much water our system uses when our pump is on.
What type of sensor is that? I guess.
So we have for the water, we have a flow meter right here, so we can tell when it's on or off. And then we also have a sensor.
Oh, so I mean, like, how much of the space is like the soil versus the system that you're coming?
How much of this is
Yeah.
So that right there is literally about.
Yeah, this is not so.
It doesn't take very much space because it's just that.
It's simply just
this is just
suspended.
open.
Yeah.
So it doesn't need all of the space. It grows directly down.
Ideally, you can get plants, closer together
Yeah,
and on a
closer
larger
together,
system.
together.
This is just kind of our
If you
approach for the
kind of see
display.
right there, like, just shows how this is lined up. They can be very close together. They don't necessarily have to.
Just grow that yourself?
This one, no.
Okay.
We transplanted this one.
Okay,
But we were growing lettuce for a while.
Okay.
So we transplanted this one for today.
So the roots are basically spread out.
Suspended.
Yeah, they're suspended.
Yeah.
Yeah, you can kind of see right there. Someone
I see. Okay, and then the water is easier. So the soil, like, so is there any benefits to the soil? Then, like, there's
So
no.
it uses nutrients.
Yeah.
It doesn't have soil, so we have nutrient that
I see.
Came all together.
I mean, like, of course, the communications.
We have our live feed.
Space and stuff. It's kind of
Yeah, it's massive. Like, a lot
The webcam, yeah.
Not much really happens, but
Yeah, exactly. So we were running with lettuce and basil both. They were both typically easy to grow. Don't need too much water. Don't need certain exact specifications for lighting conditions. For demonstration purposes, it's nice because you can show up with a plant that's a little too But the idea behind it is, you'd be able to control. You have really high control of how much water is feeding to it.
So this is like
how much light is getting, the temperature, and then there's potential. Our initial design had fans, and we were going to put fans in the back so over the pump in the fresh air. So our sensors here, or if it's too hot, it's good for just a little bit of exercise.
You guys mind if I scoot you back a little bit?
That's what we're. Oh, not at all. Yeah. Here, let's. I guess we should probably. Slide some more
Do you guys just do this project, or you guys have all
That's why we give this instruction learning how to
So
like
this
program these Arduinos, how to write Python,
Oh my god.
Oh, that one's
Yeah.
that wheels. Yeah.
That's the one I bought with you. Yeah. Oh my god.
Yeah, it's awesome. Yeah. See,
What did it change today?
First impressions overall. How does everything look?
So of course you sacrifice like as you probably like layers of box.
Oh yeah, there's a box.
And like maybe like the light has to be that high.
Not necessarily, it was just like for practicability, because something like this. Oh yeah.
You want to
I mean,
something at height.
yeah, even like if we had more time, we'd seal the box and add some fans and put CO2 into it, like how much CO2 is in the system. If it needs less, then we add fans, and then we add a CO2 pass, like reduce some CO2 in the system. And create that. The lights, the sensors actually let you know, like since it's open, it'll let you know, okay, after so much time, what did the plant get the necessary amount of light it needs to grow? If not, then turn on the light to make sure it gets concerned.
focused on some sort of capacity, so it's not like wasted, I
Yeah.
guess.
So if your lights need to be turned on within a day, then it doesn't.
Yeah. It's like continually learning.
Yeah.
Step by step.
Optimizing whether.
Yeah, that's cool. Can I take a picture of this?
Yeah, go for it.
I'm trying to take a picture. It's not letting us.
Yeah.
No, you're not. Okay. No, you have to be.
That's not a
Okay,
hard
bye.
thing to do.
Nice Can I still use that?
Yeah, nobody has
Oh, the website's not working for you now, because we don't have ours.
I'm busy working on my job.
And the light. I'll go down. And then the light.
I like it. I like it. Da. Is it? Oh, I see why. I was at the lights on. It's just.
It's just hours.
12.
You see, your house is really dark, so we have all this. But I'm saying, like, let's say, like, you have it in a room where, like, just the room light is on.
It just turned into that.
Just does some miracle grow. Yeah, no, we realized the lettuce is looking a bit sad. So, for the presentation purposes, we'll
That's a good idea.
So
have you guys operated this while it's sitting here?
Yes, we just plug this in, and this kind of gives you a sense of how the roots are hydrated. So this, just sits directly below, and turns on and spritz the roots for 20 to 30 seconds.
I really like the camera.
Then our humidity sensor in here check to see what below the threshold.
You guys put in, there's not really any soil, so is there some kind of sensor that, go ahead.
This is like what it's suspended.
It's an insulation from
Yeah, it's
from your house.
It's an
Just
organic wool,
fiberglass?
organic wool that it is suspended in.
lettuce out of something, yeah.
Yeah.
Well, it wouldn't, water wouldn't absorb this. So, is there like a sensor that goes in here that tells you how moisture's inside?
We just have one in this box. So this, underneath the hood, if you will, this will be more or less enclosed. So there's a humidity sensor in here that can check the humidity around the roots. So that's our thinking, if it's still too low of a level. I think that'd be better, honestly, if we had right next to the roots. So that could probably limit it even more.
I like your tape. It does make it look better, actually. I think it
Yeah, there we go. Yeah, just cover up a little bit of the
screws and
silicone,
stuff,
the screws. Yeah, exactly.
Yeah, it makes it look more professional looking.
There was a bit of a.
She was like criticizing black tape so much.
Who?
Not you.
No, I
Yeah, I didn't know what to expect from the other groups. Apparently, have systems, but I put them off in some places. So it's nice to have like
the
a
shower
full
one. Yeah, you got the shower one, so you got photos and stuff. It's not as effective.
It's helpful, definitely.
It tells you something. But, yeah. And this is a fluorescent light or a grow light?
We were thinking of doing an LED panel.
Oh yeah.
Red or blue.
Mood growing.
Yeah.
Put some speakers in there, just
Yeah,
some music.
They say rap. Boom, 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 boom.
Oh, that's right. Yeah, the plexiglass.
I don't think it, I don't get the time. So some of the guys are just like, you gotta make sure you're trying to get some exercise. Make sure there's a weight on.
You get a fan in there or something. What happened? Is there a fan?
We were thinking of doing that. We kind of ran out of time at the end there, but ideally we'd have, you know, just little computer fans in the back panel there cut out. They just blow fresh air.
How still is this song?
But instead we just left the top open and
Oh, I see.
it'll regulate itself. How's it going?
No dirt.
Yeah, exactly. So growing,
It's growing fine.
yeah, I mean, there absorbs enough water. We put our nutrient solution within the water here, and I can show you a quick demo. But the plants are kind of surrounded by that, so that helps it stay in place in these little
Yeah,
cups. And then the roots can sit below. And then these will go off periodically to make sure to spritz it when the humidity gets too low.
What is this made out of? Is it just
It's just some mineral wool that serves as a medium to grow the plant.
and then you just use these?
Yeah, so we dissolve that into the water that's in the basin here. And so then that provides the nutrients that's lost, whereas normal, you know, basil or plants will grow in soil, and that's where they get the nutrients from. So this can help
You're gonna
remediate
continue
that.
growing it until it's like really big?
Possibly, yeah. We might have to return on some of the materials for the class, but if we can, you know, switch some things out, and
You
we have to get
have
something
to,
going.
yeah.
Make sure it reaches the height.
Take a picture and then you have to show like a big bushy.
Oh, yeah.
Yeah.
Exactly.
If we had more time, yeah.
And so
We'll keep it going after this.
So the nutritional content of the basil is, you think this is, will be the same as one that's grown in the ground?
I think so.
If we have an organic solution, I'm pretty sure we'll get the required nutrients that needs to grow and be safe enough to eat.
Yeah, and then how much water is it taking to get as opposed to like growing it in the ground versus this?
So I mean, there's, you know, different numbers from different sources, but it seems that about 50 to 70% of water usage can be saved. You know, this is just drop whatever the excess is, just gets dripped back down.
Yeah,
and
because
recycled
it's
back.
contained, right? Whereas like in the soil, it's just spread out all over.
Right, you really reduce the amount that's evaporating and the amount that's just seeping into the soil. So yeah, they'd be perfect for a couple of years.
Start them.
Yeah, please do. Yeah, good luck with it.
All right. That seems to work. And every time we do it, so let's see how this is. Oh, that's get too late.
Just put like a little
And so this is
Just to absorb.
But you didn't. Okay, so you didn't like it's just a little bit of research to see. But you use more Wi-Fi.
Oh no, the grad students seem to be doing it. Grad students seem to be doing it.
They really yeah. They just have a lot of work on it.
Do we have the that other cup? Could we put a basil in this and say just to have one outside?
Maybe we can extract.
No, there's more basil than that.
Yeah, do we have that fourth cup?
Oh.
If not, I can take one out.
Either way, I mean the picture is fine. I think the picture's fine.
Yeah. I think just point to our picture.
just like the beach, just hang out.
We have enough.
Yeah. So you can see, oh, there's how come the sun doesn't show that?
Yeah, I checked too.
It's definitely supposed to.
So integrating that how to mesh everything in space and everyone talks about building Because once they start getting these hard numbers, they think they should out. But if you focus on certain comfort, which is itself almost entirely perception, you don't actually have to edit it. That's cool.
Like when I was listening to other people's like no, it's just like when you listen to a podcast, they're like different things. Alright, I feel like that was yeah, we'll hold it down. We'll definitely.
Yeah. It smells so good too.
Fridge and chill.
Yeah, yeah, that's my favorite.
So good. That fridge and chill.
I can't believe someone asked. I was like, where can I taste this?
Oh, really?
Yeah, she was like, oh, where's my taste?
Say Whole Foods.
Fried chicken.
You should do. She's like be super serious about it.
Very tired.
Should I fuck the rest of the plan? Or just like sample?
No. I want to eat it.
Oh, you want to bring it home?
I want to put it in a salad. I have balsamic almonds. That's fine. You can.
Guys, where can we get caprese salad? Or sandwich?
Right now. You gotta make it, yeah.
We eat tomatoes.
Just tomatoes and mozzarella.
We should celebrate after that. You get caprese salad.
I thought we were gonna get beer stuff.
That's true.
Right now for you.
Ready? Wait, can we get our 400 member?
Yeah, sure.
Yeah, we know if it's going to be like surprise evaluations. The guest judges don't even tell us who they
Yeah,
are.
they just go through and it turned out to be the singer judge.
Did the other guys come by?
I don't think so.
What is
I think you might have.
Oh, okay. No, yeah, no, I actually told them to say that. So that they could get like the whole presentation. So yeah, I wasn't quite sure how it worked out, but then I realized they should just. Yes, so.
Let's start. Yeah.
Okay.
So our primary motivation for creating this it's been like debated. Some people say up to 70%. I think it's because they're including and just even individual that they are simply suspended. Yeah, that's what it's for this system. The advantage But here, any excess is actually just recycled back into the soil.
Oh, go off.
In a few seconds as well. And so soil primarily provides nutrients for the plants. Since we don't have soil, we're using the solution package instead of the solvent of the so the water that drips off is the recycled package.
And then is this underneath here?
Yeah.
You pull it out so you can see.
Yeah, just like that extra. Ideally, it sits right below, so the roots are right where the spray is hitting. And so then the humidity sensor here, check to see if it's too low, set out. For our lettuce and for this more simple lettuce to grow, we just had to have our test had a dummy system and all that just went off every 15 minutes.
We just have to clarify. When it's I guess.
So it's so right now it's just scheduled. And presumably
Get back.
using water based on what it's sensing. So right. So got it. And you have the platform to do all these things. Me actually observe some more details here so I can yeah.
So what we were doing before,
So the Python script runs once a day to process the tweets. So, and is that pretty straightforward to set up?
I think a little bit, the challenging part actually was
Got it.
right now.
Oh, I see. So right now, your laptop is right here. Yeah. Awesome.
And then for a full schematic, how it all comes together, different elements. There's always going to be a sensor on the top. So on the board, these lettuce, there's two photoresistors and a temperature sensor.
Yeah.
So that represents those. Each file is illustrations. And then in addition to that, we have a flow meter. We read back how much is actually coming through the pump.
Where's the flow meter?
So that's right on the other side of the black box right between
Cool.
the PVC.
Nice.
So that gives us a somewhat accurate reading of how much water we're actually flowing through, and then we can estimate that a certain percentage will actually absorb into the roots and the wool And then everything, just comes out of, there's an extension cord coming out of the back of the system. So ideally, you can just plug that in and let it sit. And with given a Wi-Fi shield working and a couple of less limitations, then it can run on its own. So an extended amount of time.
And then how about this the pump with the valve? Is that working? I guess I saw it, but didn't focus on it before.
Oh, I can plug
Or
this.
you can plug it back in. So this,
Yeah,
this we found works a lot better than the initial spritzing with the servo idea.
Yeah.
The fountain system works real well in that it just collects everything that's dropped right below. You line these up with holes in the platform so that it's a direct spray.
Do other hydroponic systems work this way? Or?
That's where we
It's fairly
purchased
common.
the spigot from hydroponics.
Oh, wow.
Top
Okay,
spigot. Yeah, we purchased this and the spigot from there. So that tends to be how we use it.
So, what do you guys think are the most valuable skills you can learn? Tell me, you're the customer of education. What was the most valuable aspect of this?
Well, I think it varies between each of us because we focused on different elements. For me personally, it was the more hardware elements of things. I really learned a lot about circuit design, and building prototypes, and putting something together. Working through different limitations and struggles within the design process. So that was personally what I did in large part.
So I don't come from a farming so all of this was very new to me. Seeing even like Arduino board. So it was like very interesting to see how you could really actually and simply building this box as well, like computer. It's really good to see how we can all come together.
I looked at it a little bit more from like a software perspective versus the civil process. It was really interesting to see them. I think how you're supposed to make it work. I think it's still like a challenge, right? It's still fun. But just systems, like, they're very, very complex. A lot of the challenges are just your physical system. And ultimately, is that so, I mean, of course, yeah, over time, you can see
The class is very much like a mashup, right?
yeah, it's very, very interesting.
And maybe part of it is giving confidence that you actually can make things up. You don't totally understand all the details of how the pieces work, but things are modular enough that you can rapidly mash up.
Like, we have no impossible back yet. It's kind of like, wow. No, like, there's so many different parts. Once you're specialized,
I think that also goes into a lot of, for all of us, I think we also gain the idealization of where some of the equations that we learned in the other classes are coming into effect. I know personally, like with running through, we could optimize this, we could optimize energy, water flow, a lot of different things, and so you start to piece together where different elements of the equations fit into what you're sensing and how you're actuating.
It's not for me, I got more like the full connectivity of getting this whole physical system and getting all this raw data and doing something with it. That's why I do it. Sometimes we learn about all these like physical problems and they can all
Yeah, I don't know if we didn't give enough particularly our jobs to read not just plug it in. You can do that this way. We hope for something bigger. So then you have
Thank you.
all right. Looks like you guys are
Our plans here.
Oh, we didn't even talk about that.
This
We never even mentioned
Oh shit.
no, I'm sure we
have our spritzers.
Oh,
Yeah, exactly. So we put just water with our nutrient mix some kind of solution in the bottom, and since they're not sitting in soil, that's so then this can periodically. We chose basil. It's easy to grow, and for a presentation, so we sense both temperature, humidity, and the light. So there's a humidity and temperature sensor here, and then behind the lettuce or the basil, there's so this is our irrigation system. So this basically sits underneath the lettuces or the whatever plant you have inside, and you can set it to go off how much you need. We have a humidity sensor here to control that. But essentially, this is what happens: the pump just runs water through the system, it spritzes the plants real good, and then any excess falls back into the fountain. And so this goes underneath there, sprays it. Exactly. Yeah, we just took it out for the demonstration purposes. Yeah, this is basically the main element that sits underneath. We have in here another Arduino controller, and they communicate with these Zigbee little radio tools. So this one takes readings as well and sends them to this main board, which is controlling the system.
What are we growing here?
So this is basil. We just basil is a bit easier to grow. Generally, it's a different system than just your traditional soil growth. And so a lot of the time you can shock the plants, you can transplant them. So we picked something that we would have the best luck that would stay looking decent for our presentation. But ideally, you could grow anything, even if it takes a bit more water or more light specifications.
What about like carrots or beans that you're eating?
It might be tough for a root vegetable, I gotta say. I'm sure there's a way to do it. I mean, they still have the roots that hang down. We haven't looked into quite as much in that.
Give you a challenge.
Yeah, exactly. But companies like General Electric, they have larger scale. Quality of photos turn out as we had hoped, but they have larger scale systems like this.
No, I asked them what is it going to
providing a system like this.
It's Oh, I actually want to move into it.
Okay. So these microcontrollers that we use are called Arduinos. Last digits of that.
Oh yeah.
So we just merged a garden Arduino to name our project. These ones are Arduinos. So they're just starting with the A. Is the name of the software and the microcontrollers that we use. And make it really easy online. There's a lot of Internet of Things databases where everyone who's worked with Arduinos can publish findings. So there's other people have set up systems like these where there's a lot of the code to run the pump, for instance, is open source. So you can see what other people have done, modify it to fit Arduino, and produce something with relative accuracy. Thank you. Yeah, thank you. Thanks for coming by.
Oh, this is just a live stream.
It's not that interesting.
Yeah, it's the same thing. The cameras are there.
Yeah, it's essentially an indoor farm. It's called an aeroponics system. Aeroponics basically means grown without soil. Yeah.
Do you have any questions? Or? Yeah.
These are just little miracle grow things.
Yeah. Because soil provides nutrients for the plants, and simply because we don't have soil, we use these packets instead. Thank you so much.
Yeah, I feel like people try to do it sometimes.
I'm just watching it.
Oh, did you put the wool in here?
You did it, so.
Like, oh, you put the thing in there?
Oh, I put a little bit just to absorb it. I mean, in the 2-hour demo, I don't want to damage it.
Yeah.
Kind of was looking at this like, how wet is that getting? I'm actually gonna dry it off again.
Hide the evidence.
Do you want to present to all the guest judges?
Individual.
I thought they were gonna come in groups.
Yeah.
That's what I thought too. I think we're going to get our judges to come around separate.
These are awesome.
Oh, so they'll come.
They'll come all together.
That's good. You gotta point out the live stream. You gotta have the live stream.
It was so funny. I was like, first impressions, how's everything looking? And just like, well, this whole box was a mystery up until like 10 minutes ago. So I'm definitely relieved. Yeah. He was like, I was really anxious. But also really nervous. I kind of look good. It's like wow. That was unfortunate. My roommate came by, so that's 3 now. But during while Warren was talking, he was like, stop. I was like, these are professors. Oh, that did. I'll give it to you. I'm just sad that that didn't.
That use the power. We're like, oh, by the way, it's 25 gallons. The average is 20. It's like, and then you try to find the students, it's like,
Yeah, I guess that's what I'm saying. You know,
we have
It's a Buddha. Your videos are just practice. What would you say is average time to set up a video? No, I mean like to frame it, not to take it. How much do you need before?
Like frame, like
to set it up, it would be a good shot. A good angle.
Yeah, 1 minute or 1 second.
Usually, I'll only take a Snapchat if I see something like, wow, that's amazing. Like this, I saw this. I was like, wow, that's amazing.
Snapchat, I'll pick it up.
oh yeah.
Right. Because you don't have to.
So actually, what that lady said was a really good point. Having humidity sensors in this would make more sense.
No, that's what I was telling them. Like, that's why we can't regulate it, because it's like you can't.
But this is what we would have.
Also can't really put it
Yeah.
but that's because it's like
Yeah,
the whole point is that you're like roots
Saturated.
But that's why they have like the
similar to soil. I feel like you could the same things you put in soil, you could stick into that. You know.
Yeah, but also you ideally don't want this. If you build that part correctly, you don't. So it'll be easy. It'll be more water efficient. It's just like a net. So if you grow it from a seedling in here, take this out and
You just have no way to suspend it then.
yeah, you're not.
We can 3D print out some better caps.
Next
I don't know how physics works, but how does the humidity in here change?
It's basically this water when it's being spritzed, it's turning some of the liquid into like gas, like the water vapor. Yeah, so it's just kind of like spread. You know, like when it's being misted. You know, like when you mist in the air, like that's gonna change your humidity. I mean, it's only gonna be very slightly, and then most of it just falls. Yeah, exactly. Usually, it's like relevant to heat too. So, like if it's warm, the air can hold more water. But I mean, it's water vapor. Basically, it's measuring how much water vapor is in the air.
How you guys? That it is. Irrigation system that we took out of this box right here, but it basically spritz the and simply because we don't have soil and soil provides nutrients, we added this solution.
So here's a a demo of basically what's happening. To our system, we imagine something like basil doesn't need too much water. But for things that require a bit more water, you can cater to those. So right now we have it right now for the demo it's 20 seconds on, 20 seconds off. Usually it's on a 15 to 30 minute increment period, just splits it for 20 seconds.
Is it just time-based, or are you guys using the amount of water you put in?
So there's a couple different ways we measure the water. We have humidity sensors in here, and so just we can get a relative gauge of how much water is in the air within this box itself, so that we can estimate. Well, actually, we also have a flow meter on the pump, behind the pump, so then using that we can see on each pump cycle how much water is flowing through, and then estimate a small factor of that amount would be actually saturated onto the leaves themselves. So just through analysis of how much water is flowing through, we can gauge how much it's getting, update the system accordingly. So other than the irrigation system, our Arduino controls the light on and off. So we have kind of a catch-up-based lighting system. So our equation didn't really turn out too well, so I'll just describe it for you. Basically, the photoresistors in the board here behind the lettuces, those are going to sense the light intensity on every frequency. So what we've chosen is every 15 minutes to check the light intensity. And so we estimate, about 160 out of the 255 reading for photoresistors, just what the numbers that over a 24-hour period, we say about 160 for the 14 hours is what the basal right now is based on our research. So we have a intensity frequency. We need just over 2,000 intensity hours. So we basically knowing that, we can sense the light, the ambient light, as well as the light from the direct source. So if it seems like the rate, we'll check the rate just based on this 15 minutes. If it stays at this constant rate and the light's off, we don't need, it's going to hit our threshold. We don't need to turn the light on. But if it's a bit darker, now it seems like we're going to have to switch it. Yeah, we don't predict the amount from at least like the sun or the deer. It's just checking the light. Right, and there's there's certain combinations, right? So if it's not getting enough light while having the light on for the full time, we'll have our server basically, exactly, set by Dr. Wu, set so that generally describes how hardware is. So then with our data, then.
So when you say you're using Twitter, so it's not private, it's yes, so I can see, and you're just doing action on the user's So the reason for that is so just, I mean, this is totally a question, but if you were to take this product and say, like, I'm selling you, so my thinking is you would sell like one of those pods, and then there's a way for me to program that Arduino with my cell phone to sign up for Twitter. And then it says Ambrose, add to Ambrose limit.
It just makes it easier to Oh no, yeah, we're using our own private. Yeah,
letting everybody just mind their own. I'm going to Hawaii. I'll see you later.
You can do that.
Or someone can hack your Twitter account and
because once it's actually set for temperature, there are actually some habits. And all the sensors are functioning by our people, and they are and so
Our data analysis portion.
As you can see, I mean, given our temperature sensors, I mean, it will tell you whether it will have a minimum and a maximum. If it's say, it'll tell you like your plant is in an area where it's too cold, move to a warmer area. If it's too hot, move to a cooler area. Our photoresistors, as Peter was just saying earlier, if it needs to be light,
So, can you tell me the components that have a closed feedback in the actuation? So, like, something changes, I sense something, making precision, and I act on it.
So that, I think that plays into our right.
Yeah, that's just the light. So not the water.
the water we kept at relatively stable.
That's where the condenser built in. So it gives a relative reading rate, which is quick and then talk about humidity.
For this purposes, we have sensors because our water is saturated. So there are certain drops.
Not really a presentation.
Yeah, so you can't just get one notification. Yeah, it's like it goes up to
Because I mean, like, I think we
The data flow.
That's good.
I'd love to meet you all to start with. Mike, did I have any of you in class? I already know you.
let's go get 2013.
Maybe 7 with me, maybe. So, are your names up here on this nice poster somewhere? You're engaged? Are you civil engineering majors? So tell me what your project is.
So the graphic is the worst. But that would be great as
It's so weird we have comments like that. Like, is that insulation for your house? Like, a lot of like plant like gardening stores sell just like an organic wool fiber. Just kind of
So it's urban.
yeah.
So this is basically the same. They're inside the stock for this irrigation system to pick it up and purposes. And then the river simply just send it up.
So yeah, we have a quick demo here. So essentially, this is how the watering is going to work in irrigation. Yeah, like Andre said, this is directly below. Goes off, periodically depending on the plant. The user puts it in the specific water needs for whatever they want to grow.
So what are the sensors that give you feedback that say, oh, I need water, I need water?
So we have a humidity sensor in here as well as a temperature sensor, and so that can sense, the ambient amount of.
So that's up here in this, in the plant environment or down below?
That's in this little black box here. So this is completely enclosed below,
Okay.
and so that will just sense within where the roots are. And so in addition to that, we actually also have a flow meter that tracks how much water is being pumped in each cycle. And through that, we can estimate, a factor of that will actually be absorbed 5 to 10% tops, absorbed into the wool or the roots themselves. So we can estimate, based on that, a little bit more, just get a general idea. But then other than that, our Arduino will control the light based on our photoresistors, which are just in the back of the box.
Is that just a normal fluorescent tube light, or is it a special hydroponic one for?
It's just a regular fiber light.
Okay, so it is kind of specialized for
low energy usage. In terms of the bulbs, we're gonna go LED. A little bit easier to do that.
In the professional setting, I tend to electric because they found the proper combination.
I see that in the photos.
Yeah.
So actually, putting this together, it was really great having a new facility here. In addition to both data salt and kitchen, trying to utilize all of our resources. So building this was actually really awesome.
Yes, if you needed something to get a hardware or something, it was here, right? You could get a lot of stuff you need.
Yeah,
The
one thing.
sensors that they're embedded in us here, and then they're
So it was fun being in Jacobs Hall, or you'd rather have been in Davis, or?
Oh, Jacobs.
It's a lot more light.
It has some windows. The dark.
Everyone's been saying that. Oh, those windows. Oh.
Actually gauge the time of day here. Giant window. But yeah, it's been enjoyable the whole semester. But anyway, let's get our analysis.
Yeah.
So we.
We want to go with the second.
Yeah, I was okay. There's also like system. So after all of this is being planned in this one. There is a Wi-Fi shield that works with the system. It communicates this data to Twitter, which we're using for and we're data mining all our sensor into a platform. And that is creating being fed into a website.
Yes, we have a aeroponics system. Your garden. So we have our basils here that the roots are suspended below, and this is our irrigation system for it. This basically sits directly below the plant. And I can show you a quick demo actually. We have a small pump here that flows through. We measure how much water goes through each cycle. Based on that, we can get an estimated fraction of that we can say will be saturated into the plants themselves. Whereas the rest is just fall returning back into the basin. And then we also have humidity sensors.
As you can see all these graphs, it'll tell you
how much water is
essentially
saturated.
the ambient temperature. If it goes above 85, it'll tell you, oh, you need to move your box to a much cooler area.
Since it's aeroponically, we need to provide the nutrients somehow to the soil. So that's what these little packets are for.
It pretty much serves as a check if our humidity levels drop
we found,
then we know to spritz
similar levels of nutrients.
If it stays pretty constant, we know we can try and start along.
So then we also are controlling the light at the top, turning it on based on what our photoresistor is.
It'll tell us,
You'll see,
our plant gets enough
have an estimate of how much light the plant might need per day, and we can hit that goal by checking progressively with either the ambient light from around, or if that's not providing enough, then we can switch to sector. So we do a check every 15 to 20 minutes.
Well, for one water usage,
Supply the roots with water.
Oh yeah.
No, not quite. No,
I think he mentioned it
we have.
earlier.
I had to actually put in some research. That was our initial thought as well. We're like, well, the rain
Clean off or something?
Yeah, clean, exactly. But that was actually mostly for like since it's a closed environment.
Oh yeah,
we don't have to
definitely.
worry too much about debris or anything to fall down. Pests, especially, that we didn't have to worry that much about.
Yeah, no, I've thought these over the years. We had this little egg once, and then rain and temperature control. So if you made these like little egg kits or something, and you could sell them, and you just plug it onto your computer, or it'd be Wi-Fi. So you create something that your computer can talk to. You wouldn't have to.
Right.
If you ever want to do that, I used to teach entrepreneurship for years here.
Oh, you did?
If you ever want to start a company, I'm just Berkeley@gmail.com.
Berkeley@gmail.com.
And this is cute. I mean, you could sell it. You could sell this as a Christmas gift.
Yeah.
Because you heard about this company that started a bunch of students use coffee grounds to plant mushrooms.
I heard about that actually.
And they're now like doing over $10 million a year. They're doing bigger than that.
No kidding.
So you just get a little self-contained thing.
Yeah.
Scale it down a bit. We went a bit overkill for the presentation.
You make it
size,
small.
but
You make it small.
Yeah, exactly.
We can plan and write. Well, if you ever want to do something like that, you have my email.
Okay. What was your name?
I'm Baron. Yes. And you're both studying.
I'm a civil engineering major.
I'm a CS major.
Okay, so good combination.
Yeah, exactly. We found our strengths benefited each other well throughout the
I can start talking.
Yeah, exactly. That was where all the research had to come into play, actually. I don't do too much about bonding 4 months ago. So. yeah, definitely learned a lot in that realm.
Nice project.
Thank you. Thanks for coming by. I'm sure. Yeah, it works pretty well. Yeah, so yeah.
That's true.
It's
Oh, there you go.
It's like, yeah,
yeah, I
Sorry to know everything about your shit, but
yeah. Here's all the hard.
it looks good, man.
This is like the final product essentially. We got our USB plug coming out of here, so you don't even have to open and close. But
Why is there a camera in there?
live stream, baby. Live stream.
I thought that was a picture.
Nope.
No, it's a live stream and it's YouTube.
yeah, we don't talk about
Really?
it.
Yeah, we need to point it out. People always forget that there's a live stream.
Oh, that's
Yes.
funny.
It's being projected onto YouTube right now.
Whoa.
Oh my god.
Oh,
Maybe if we show their faces though.
Yeah, we should show people's faces. We should just take the camera out.
So is that like a light monitor?
Wait, Andre, just
Yeah,
take
so in the
camera
back
out.
here, there's 2 photoresistors, which is light temperature sensor in the middle.
Take it out. There you go.
So that's just
wanna
regulate
be in the-
light. And
What? Take it out. No, not yet. Just take it out. Because then people will know that. Oh, there. Wait, it's really funny.
Oh!
Oh, no. That's pretty funny. Yeah, we keep forgetting that we have
Wait, you want to put it on the back panel?
Oh, wow. People can see themselves.
These things are Arduino. This is called Arduino. It's the platform that we do everything on. Basically, it's like it's a software.
Arduino phonics.
Yeah, exactly. Arduino phonics.
Right here. What happens is,
So that's it. This was my semester day. This is what I did instead of bridge in shop for all those hours. 10 hours a week. No, I actually slept a lot. Wait.
community sensors that
Thank you. Yeah. No, he can't learn that. It was so awkward. So Harley is the new department head. Or the, yeah, I don't know if you knew that.
Yeah, I
That was so awkward initially.
I was just like, so cool.
Like I was waiting for Andre to introduce himself and like start talking.
Yeah, he did.
I was like, I don't want to just like.
That's what he's always like.
This actually is cool now.
This is cool. We should have done this when Mario was here. Oh, what burger comes?
You guys got burgers?
No, Eric Burger. Oh, it's our GSI.
That's the name? Wow.
When the burgers come, you know.
Dude, that's literally what I heard.
Eric Burger, dude.
The live stream fans growing.
The live stream.
It's like so like who's gonna tune in? A live stream of a
You
plant.
can follow our Twitter and their YouTube. So,
Yeah, there's
you know,
we do have a Twitter
they
feed
have a
too.
Twitter feed, and this will be tweeted.
That's how we collect all of the data.
Yeah.
We just have this basically uploading all the data to Twitter, and then it data mines from that, and then
You guys have 7-9 followers?
Yeah, we're followers.
Had to.
Humidity. Oh wait. Humidity is currently at 75.
Look at Peter Jonas is following us.
Which Peter Jonas?
Both of them.
It's when he followed you back.
Art
You
of
thought-
Africa.
He like searched up Peter Jones and found that guy. Thought it was me or something.
You didn't think it
No,
was
I
you.
didn't.
You just followed me anyway.
We're following a lot of cool
Okay.
people.
He followed you back.
Oh, a lettuce plant. Before it was called Arduino lettuces. It was like Arduino lettuces small. Like, so right.
Now we're good. We changed the name.
I think it's better.
Why do you guys post on
Yeah,
Twitter?
So that's basically our database where we can put all our issues. So this is kind of low power, low level analysis. And so we take all of the data that it's sensing and send it to a Python script essentially. And so to do that, we just decided Twitter was easy enough. It's already a platform, and so we can just pretty easily set up something from here to send to Twitter, and then the computer itself will mine from that.
There's 20 seconds delay. Mr. People just.
Huh?
Oh, because there is the delay. Yeah. Yeah. No, it's true.
Check out. Yeah, we gotta go check out theirs.
Sounds good. Thanks for coming by, you guys. Where's Legs?
He's coming.
Thanks, Jeremy.
I'll head over and see the live stream.
The live stream, we really gotta play that out.
We need some.
Oh, yeah. No, this is funny.
Just have him stand right.
Yeah, no. I'm gonna run out of batteries.
Oh. Yes. Wait, Anders. Eric is here. See it? It's a live stream.
My computer's about to die. You're famous.
Yeah, the live stream on Basil.
Yeah. Okay. So our project was called Going to we basically created Aeroponically means grown this is the growth chamber. This is the irrigation system. For presentation purposes, you can get outside of the growth chamber, but it's probably takes inside. And whenever the plant needs water, I can plug it in to show.
Yeah, we have a quick demo. We have a 20-second on, 20-second off cycle. But this is, the watering system that we've come up with. So this tank basically sits directly below the plants in the box. Just took it out for the demonstration, but we cycle it every 20 or 30 minutes, depending on how much water the plant needs, and based on the humidity sensor readings. What we also have is a flow meter, so that we can estimate, we can see how much water is flowing through the system and estimate based on that percentage that'll be absorbed into the plant per run. So in addition to that, we have the light control just on the on and off, and the equation basically that we have to model that is kind of on a catch-up base. So it'll store all of the readings for every cycle. So if it's at 15 minutes, for an hour, and over that on a day period, we expect about 14 hours of sunlight. For some plants, that's also varies depending on what you put in the box. So basically, that's your target to reach. So then you have the anticipated value, which is the sum of all the previous plus the current times the rest of the time. And so then that, if it's too low, you turn the light on. If that's too high, you can turn the light down. But if your light's already on, it says turn the light on. That wouldn't really make as much sense for the system. But on the other end, if it's not getting enough light, even with or if it's getting too much light, So if it's getting too much light, you're on your website or set up, you might want to find a more shaded area of the house. So that's kind of how all the elements kind of come together to perform.
And then
And for our analysis portion, I'll start off with the humidity sensor. Essentially takes readings. It'll let us know if the humidity levels are too low, then we want to release more often. If we notice that it stays pretty constant throughout the system, our temperature sensors, we have certain thresholds depending on the time. If our temperature falls below a certain threshold, we take notification to move to a warm area or cold area, depending on what we read. Our photo resistor does the plant get enough light that it needs? If it doesn't, then we turn on the light. If it does, we turn on the light. So that's how our analysis
Water.
What are your biggest technical challenges?
for example,
yeah, for me personally, it was like some of the factors, something like we just had an error that we did not know how to solve because we don't have that CS background where we understand like why how it should be working, but we don't know why. It's like one bug that we have, we don't have a very good understanding.
What was your biggest takeaway from this?
Eventually we can get it all like web communicate with Python communicate to Twitter, to the website, and then back.
Very good. Prototyping as well. Troubleshooting. What to cut. I mean, the biggest problems too. And we thought we had a few ideas that we wanted to put into this thing. And we just a couple of years now.
Get it in the truck.
So this is our section. There's a temperature and a humidity sensor in this chip. So then that's cross.
I was in David's shop yesterday. Peter showed me.
And then that's the data there is sent over this right here. And then the larger one has prepared
Live stream. Oh wait, can I hear us?
I don't know if I
and the
have an
humidity,
audio.
so you get a real percentage.
Like the tape and everything. Yeah. See, we were like debating.
The tape off is much better.
It looks cool
No, it looks so much better without the tape.
because you can see the building.
But like, it's not that bad. I think it looks cool when you can see the redwood issues.
Yeah.
And then this, I don't know. I thought it looked
I think it depends on how good
Shops provided
We had a go over there. I was really sad about that.
So we're fortunate in that.
Just a little bit. It's really good overall. All about the research. Exactly. Really?
They should just
Really are seriously. You got you, three more. You guys. So this is what's inside there.
Yeah, I think you can see.
So it says right here, right underneath the roots, and the roots just hang down.
You can brush this off
It would be fun to try to estimate if you really did go. No, I mean, I see the summer.
and then it's also good. Right now it's very
So one thing.
But yeah, I did.
That's actually how. So it pays a lot of attention, like Dan Cameron and you guys do.
But for our operations,
Went to Harvard.
so
We had an operation day. Beautiful.
that's how it gets.
This is the most
It's your level. So for certain things, you know, if you're not providing
really the water very, the places where the piping system it's right in. It's the only time I've ever been able to nail I can conceive of a more efficient building. Look at that.
Got it.
All the calculations.
Yeah. Oh yeah, I mean this is plugged in constant. The nice thing is the light pumps.
The only problem is the Arduino doesn't have power. It is relatively low power as most of them. But yeah, it can be a bit. It could be optimized for churches. We focus mostly on
Trying to get motivated from my
the thing is, I mean, this really does help.
Honestly, like this class is really like
Oh, I don't think they do it every day. I would hope not. I mean, honestly, there was a lot of. I'm just saying, I don't do it.
I don't know if it's watching yet. What are we gonna do with this?
No, I'm trying to smile. I'm just trying to smile. I'm smile. My little I don't need to smile for this.
Okay, yeah, maybe that.
One of the things I love coming off is just like more stuff like this. Like, it's like more walk like that. I'm just working for like he doesn't do project. He literally tells me. I mean, days are really clean. That most is supposed to go up like 3 stories house. She works like each house for about 4 hours. Like that's like back when she worked out, she was working 2 houses, 2 to 3 houses a day. 6 days a day. Oh yeah, that's worse. I don't. My house is supposed to say no.
Oh yeah. So, all right. Well, we just want to work on after 5.
Yeah, that's the irrigation system. That's the dirt by use the water. So they have
like the system runs water irrigation and lighting and anything else.
So we have 3 sensors: humidity, we actually have water flow, temperature, and light. And so we basically just actuate automatically everything. Lightning speed, so
The temperature gets too low or something.
we actually just like warn the user that they should have the
which is more than enough.
It's too hot.
Because the users will
It all depends on like the specific
But-
line you're drawing.
Yeah, the light is regulated by a photo resistance. So essentially, it'll tell us if we got enough ambient light. If the ambient light was enough to get the plant the amount of light it needs to be healthy, then we don't turn on the light for a certain amount of period. If it didn't, over the course of the day, then it'll tell us that we need to turn on the light for a certain amount of time to reach that threshold of, I guess, light that the plant needs.
But you get the idea.
Yeah.
I think yes.
Haha.
Just saw something about irrigation system. I mean, started
The
off
drought.
with there's a drought, moved into irrigation because it takes majority of the water.
A lot of guest presentations from us as well. And it was a similar idea. We didn't have necessarily a presentation on it. Our professor, gave a bunch of different startups that have different control ideas that are similar to there was one that planted soil and then had the humidity sensors with different control. We took the efficiency route for the farming decision. So this developed from that. Cyber-physical word.
Cyber-physical system.
Oh, wow. Is it really? Okay. There's only like 2 CFs. Yeah, it definitely is.
You guys meet? Yeah. As soon as they open it, the first couple of weeks, you're yeah. You guys decided to show that.
Is that right now?
Same time, yeah.
Oh,
Can you talk for like 5 minutes?
Good afternoon. Hello, what do we have here? Oh,
We have it. Oh yeah, this is our YouTube live stream for now. But we have an aeroponic garden system that's happening. So there's-
aeroponic. Oh,
aeroponic, yeah. So
that's
there's
very fancy.
It's very fancy. There's no soil, so your roots are rested in here, and then this irrigation system it sits inside this box right here. But it's hot, yeah. But
Very
here
cool.
I can show you this. So it spritses, and then we actually we have different sensors. We have a humidity sensor, a temperature sensor, and a light sensor, and then we have a floor meter to tell you how much water is flowing through this right here. And this is all connected to our Arduino, and this communicates wirelessly
So
with the Wi-Fi shield
I guess
to to Twitter, and then we use Twitter to like provide that data. And
Twitter.
yeah, so it adds like a live view to it, and then we analyze the system within like Python. And we also have a website that has the feeds coming in, so you can see that. But the whole point eventually
This
is to
box
just
actually
show
sits right
the
under
decreased water usage. So this is
So,
very water
here
efficient.
is
This is
the
70 to like 90% because it's not in
These are
soil, so your water is
our roots
and it's
and
theoretically your water
we have the humidity sensor that measures humidity between express and out tell us.
So how do you see this competing with conventional hydroponics or aeroponics?
I think the difference is the cyber layer. So the cyber layer, right? Because we have all these sensors and all these things that are going on, and also our automated
Our
system.
system falls below a certain temperature.
So
Fair enough, fair
this
enough.
competes in that it's like it's supposed to be a lot more efficient and ultimately like optimal growth with the least amount of energy.
Cool. So yeah, what kind of applications do you guys see this? Vertical farming?
Vertical farming, large scale industrial, like General Electric has huge research facilities that do this. You guys know that like Google is putting it on top of their building. Like, vertical farming, obviously, MIT has a huge lab does here. So I mean, it takes a lot. You have to understand the plant, you have to understand the cyber, you have to understand the
Yes. Clearly very multidisciplinary.
yeah, very very multidisciplinary.
So you're a civil?
Yeah.
What team's a civil engineer?
We have one CS major.
CS major? Oh, that's helpful. I guess.
Right, so what's this?
So-
And that's how's that connected to this one?
This sits inside this picture right here. This lifts up and opens and opens this box. Yeah, so this spreads directly onto the roots.
Oh, okay. Try to like spread the humidity.
Yeah, the humidity sensors right there.
Do you see this being faster than just normal planting? Do they grow faster? Just normal
We
planting?
haven't actually been able to weather system long enough in terms of we've been designing and building this entire semester. But I'm sure once you, it also depends on the plant. We pick basil because it's pretty easy to grow. But with specialty plants, you can definitely test that. That are more or less that.
We have switchers, we have water pumps.
Seems like a commercialized technology.
Definitely, yeah. That is the goal.
20 minutes.
Reducing water. This, no, this is for the water solution because it's not in soil. It doesn't necessarily dissolve this way. So this is dissolved in water.
Above
Fertilizer of some sort.
I'm sorry?
Fertilizer of some sort.
I'm sorry, what?
Fertilizer of some sort.
Yeah, this goes in the water because there's no soil, and a lot plants usually get their nutrients from soil, so you have to put it because this, yeah, our fuzzy thing. Like, anyways, the medium doesn't really hold.
And this pot goes underneath.
Yeah, you can lift this up and hinge this up. If you come up, you can see it sits inside here, so that's like the bottom that goes in there.
Yeah, we have our webcam for the way the whole site is physical system. So, all our sensors are connected to an Arduino. The Arduino will
But that's just our
stream
for how we were measuring the
I guess the path we use to communicate between the Arduino and the laptop.
Arduino, yeah. Arduino, what Gardens?
Upload to the website.
So yeah, we didn't have the budget to get the LED lights, but these actually are colored. They're considered the optimal color for like certain
Yeah, right. Like we can regulate how
response. Yeah, respond better. So that's I think tends to be the color that works well.
How's it web interface?
Oh, it's going. These are some of our graphs. This is like very, very basic, but that's like the Twitter feed that we have. Moving background image, right? That's all you need for it to be busy. Thank you.
Who's the CS?
He's upstairs.
No, not really. Not at all. It's the first time I've ever worked with microcontrollers and any of these sensors. A little bit of deep learning, but yeah, definitely the first time I was in this course. Just getting started. Most of us were civil, and I think we all have about the same background.
A lot of Googling things and watching tutorials. There's a lot of research.
Trying to understand other people's codes to get like these flows.
Other things, for example, like we have to use integrative connection, so there's a built-in library. So we found that solving is more stable.
How did you guys kind of arrive at this?
I think we started with a job in California.
What problems can we tackle that are relevant today?
So agriculture comes from because of fact so by using that, ultimately
You get the things that work. When you were working on this, was there something in particular that surprised you or that you heard
for me, it was like the English and with like a lot of hardware, you know, stuff. I just having classes yeah, especially ultimately our goal is to make it
connectivity of like getting this physical system and getting like all this raw data that we understand as like the scientists are here, we know what's going on. So all these sensors and all this, but how do we communicate this to the everyday person and like being able to like
how do you make it like an interactive experience? Yeah.
Do you guys have
we haven't really talked about it, but we're getting more and more excited as we hear back. So perhaps. Yeah, it's definitely an area that's being explored just because of like they can be closer together. Probably the best class I'm taking here, I would say. Yeah,
it's really good.
We work in Davis Hall, right? So the room from Davis Hall. That's really cool. It's so like just like.
Well, of course, we feel like we were just saying like, okay,
So we use hardware, we can use software, we're not limited to it, which is great. I think this will be
I was
Just measure temperature from the outside I just wanted to.
Wow, your basil's so pretty.
Wow. It's like it's brand new or something. Right?
Oh, I'm on camera.
Yeah, YouTube.
Are you doing some sort of optimization algorithm?
Well, so based on existing research, we don't know.
Oh.
But if it ever goes out this
Look at this.
because
The camera
light
inside.
rather than not by the
Oh, cool. What is this about?
Yeah, you're on YouTube right now.
Oh, what?
Yeah, yeah, it's live streaming on YouTube. Just like link. Yeah, I can send it.
Who do you post the link to?
I don't think there's one. I can see what.
Oh, that's cool.
If there's a 20-second delay. Oh yeah, I'm the only person watching it. Yeah.
Oh, YouTube does this now?
Yeah, they have it's a beta testing feature right now. But yeah, they definitely have it. It's pretty cool. Yeah.
So what's your project?
It's called Garduino. It's a play on words, garden plus Arduino. We created an indoor farm for basil, but it can apply to a lot of different plants as well. And the motivation behind this was because it saves a lot of water. So I can give you a demonstration. This is the irrigation system that exists underneath these. All the excess water that does not hit the roots of the plants is simply recycled back into the same reservoir it came from. So that's how it saves water. Theoretically, aeroponic systems save between 70 to 98% water, depending on the plant and the system. But aeroponics basically means that the plant is grown indoors and without soil. So instead, we use this grasping medium to simply just stabilize the plant. So the roots hang below here and they dangle inside this dark box, and the leaves can go outwards.
So you're saying that this is underneath here?
Yeah, yeah.
And the water is caught by this?
The water hits the roots of the plant. It also dampens this as well, which helps the plant take good water, but primarily it's the water directly hitting the roots. That makes a difference.
So you just recycle this water?
Yeah, over and over again.
So what does the Arduino do? It like just into.
So we automated it already because existing research says that basil plants need this amount of water a day, this amount of light. But if it ever reaches a threshold, so for example, we provide light through this light source here. But if ambient light gets in, then it might get too much light. So that's when the Arduino detects that. We use photoresistors, and so it actually like turn off the lights for a while. Yeah.
And it's like times when you water the plants as well.
Yeah, every 15 minutes we water it. There's also a humidity sensor, so if it gets a little too humid, we will stop watering the plants as well. Yeah, so it's basically like thresholds. At those bounds, we actually.
So you like grew these from like seeds, or
No,
did you
actually we bought them and transplanted them.
okay.
Yeah.
Is this on battery right now? Or you have to plug it in as well?
I think. Yeah.
What battery did you guys use?
I'm not sure.
Because
I was
we're
not
using
in
the
charge.
same module.
Oh, really?
Yeah.
Yeah, that's our website.
You guys change everything. Or if you want to check out the other exhibits.
It's cool.
Yeah, came together in the end.
Yeah.
Oh, wow. So,
Yeah.
chose basil instead of white.
Oh, they use the.
Yeah, exactly. We were thinking of serving caprese salad with the presentation, but yeah, it's kind of
What is this?
Live stream.
Yeah, basically just put a camera in, and it's one of the criteria that we put on ourselves was to gauge plant health. So we can only do so much saying, okay, we think it's getting the right amount of water, we think it's getting the right light, but we thought, you know, virtual picture. So we were initially just going to go every day, take a photo at 9 a.m. But this was a little bit easier to implement with the time constraints. Yeah, it's adds another layer to the final product. But this is actually how the irrigation works itself. So we have this essentially sits inside underneath the plants, and so the pump just runs through, and these just spritz the roots, and the humidity sensors in there and measures when it's going to need to go. We can estimate how much water is actually being saturated. Yeah. That's how we put it to Python. Just put a Wi-Fi shield on the Arduino, send out tweets, and then just data mine. Yeah. How's the project?
It worked. It came through. It was pretty shitty last night.
Oh, really? Yeah, I mean,
great. Yeah. Had a good time, dude.
Yeah.
So
I never thought this would go anywhere. Startup, and like the guys mentioned, there's a lot of startup potential. We're like, who would? Yeah, we guys just like, you got to make it smaller, put more compact. That's a perfect Christmas gift. I would love it.
I think like,
you want to buy it?
This is a nice setup.
But yeah, we so I built most of this in Davis actually. Welding shop over there. They have wood shop in the back as well. I'm work on the bridge team, so Matt and Jeff, shop guys out. Comfortable with me coming in this for things like this. You know, the wood and plexiglass supplies. That was kind of easy part.
Yeah, I figure.
Getting all of this working how we wanted it to, and the circuits and everything was a bit more complex because you had to.
Because that is like this underneath this.
Yeah, exactly. So this is just directly under the roots. Hang, you know, here. You can see in the picture in the corner. It's like lifted up. This basically is on hinges and just flips up.
So can you use like less water when you're shooting from underneath as opposed to like above?
Yeah. So this is not only just the source, but it's the collection. So anything that's sprayed up will just drip back down.
Oh, it doesn't get absorbed by it.
Yeah, and so then we just have our nutrient solution in here. So because it's not in the soil, we have to have critical nutrients for the plants to survive. But that just dissolves.
Cool stuff.
And we learned this is actually a pretty common approach for general aeroponic systems.
Really?
Yeah, there's actually a lot of kind of research and development going on to urban farms, just because it can really save a ton of water.
Yeah.
Even transportation.
Use
costs,
less resources.
Throw it in a high rise like next to Whole Foods.
Yeah, the whole
Trim off the
skyscraper is
lettuce
a bunch of food. Yeah.
Yeah, exactly. So, awesome. So there's definitely a room for in industrial level products, and GE has
like huge agriculture.
Yeah, exactly. Cool. So, worked out well though.
It's sick. Good job.
Thanks. Yeah. Doing
I was blocking it. I was like literally. I was like, "Are you sure I'm not blocking?"
We have a wide presentation area. So putting us on a picture, we'd have to be like to the side of the board, or to the side of this, or in front.
As long as I don't want to block this.
I guess we could go from like here and get like an angled shot.
Yeah.
But turn this a bit, and we'll all just be squatting.
It's either I lead it or
I like this part though, the little tail.
Yeah.
Makes
really
it convenient for programming.
Yeah.
I'm surprised though, like us talking to I mean, I'd be down, honestly.
Yeah,
like,
I'm
that'd
so
be
down.
sick, but
If I could do it.
I mean, I don't know a lot about entrepreneurship. Maybe it is a good idea. Who knows? I'm probably gonna email that dude just out of curiosity.
Yeah.
Just have a sit down meeting.
Like I'm in the CS space, so it's obviously like entrepreneurship heavy.
Right. Oh,
But we
just
do
CS
a-
in general.
Yeah. But this is like another field. This is psychophysics.
It's like
So
the crossover between the two.
Yeah.
Engineering and the CS.
Yeah. The thing is though, I don't know if someone really cares that much about water. To the point where they rely on it.
Oh, yeah. I mean, I think it's just another one of those things that's like, you know, it can be a more efficient system, but it's too much of a force to get people to get rid of their old ways and the ease of just putting it in soil.
Yeah.
No one thinks of growing plants as like using too many resources.
Right, yeah, like our basil plant, people just buy it like that.
Yeah, exactly.
They don't need to hook up this.
A lot of the time they don't even put it in soil, they just keep it in their planters.
Right. And like fewer and fewer people are actually we buy
So
it.
this is bringing it back.
Yeah, this is bringing it back.
My initial thought, or one of my initial thoughts for our presentation proposal of what we hey, how's it going?
What's your project about?
We built a indoor farm called an aeroponic system. That the plant is growing without soil. So instead it uses this grass medium. So the roots then go below into this dark enclosed box. This is the irrigation system that we took out for irrigation. And so basically, it just, yeah.
You get a quick demo. This is essentially how it's going to, how the water flows. The pump just sprays water through. We have spigots that just mist the water out. So we have a humidity sensor in here to see how much water is saturated to the air.
And so it's this is really inside there.
Yes, yeah,
Making this spongy stuff wet.
Yes.
And that's what the roots grow in.
The roots then go below, but this helps moisten as well.
This is kind of what the inside might look like. So there's holes cut in the top here. Roots kind of dangle in, and the misting is hitting the roots and the growth.
And just the water.
Yeah.
Yeah. With the so this actually has nutrient solution in it. Without soil, you know, you kind of have to
Right, you have to give them
provide some
something.
food. Yeah, exactly.
And then is that just a fluorescent light?
Yeah, so I think we just got it from a plant supply store, grocery store.
And that was enough for the plants to make.
Right, yeah, so it's a low energy solution to provide the lighting. So the way we designed our code and programming around it is that we have these photoresistors in the board and behind, just these little computer chips that are sticking out the back. So that will read how much light is actually being displayed. So whether it's the ambient light or if it's dark right now, that light. And so then our computer code will track how much light the plant's getting per day and turn the switch on or off depending if it's expected that it will reach the desired value. Yeah, it's more of a, yeah, exactly. Yeah, if the case is that it doesn't.
And this is what class is this?
So the class is a cyber physical system. So in addition to having the physical element, we incorporate the cyber level by publishing a website with all of our data. So we have different water usage statistics, different plant health, energy usage, just to kind of track overall conditions of what we're working with. So the way we get it to the computer is that this Arduino controller, we attach a Wi-Fi attachment to it, and so then it sends out tweets actually. So we have a Twitter feed, and so it sends all of the sensor data to the Twitter database, and then our Python code and data mine to collect that, and then publish it to this feed here.
So what are you studying here? Are you both engineering students?
He's civil engineering and I'm computer science. That's like a perfect combination.
Yeah, it was a good skill set to match with each other.
Yeah. This is so cool. Thank you so much.
Yeah,
Thanks for coming by. Yeah, I'm glad you enjoyed
Let's get it going. Yeah, just say hi, Maya. Peter.
Oh,
we both. Yeah, it was the customized.
Designed it. We have this is actually our CAD drawing, just a little miniature version of it. That's we drew up first, initial design stages, and then just cut out a little bit, pasted it all together essentially. But this is our hydration system. This is kind of the bread and butter of how everything works, at least in terms of the water. So we put the nutrient solution in here, and then every so often we can control the spritzing. We measure humidity and how much water is actually flowing through to get a better idea of how often we need to set off the spritzer. But then this sits directly below the plants on the inside of this box. We just took it out for the demonstration. But it looks a little something like this, where this lid kind of folds up, and then the roots just sit in and dangle right next to the spritzer.
So technically it's an aeroponic system, so that means it's grown without water. So that's why we need the nutrient solution to supply that nutrient. If we want more supply, and then the leaves just move on top.
Did you guys grow those for
You just left them. I tried to chose the basil plants. But yeah, theoretically, it could save up to 70 to 98% of water depending on the system. Because any water that is not directly to the plant is simply recycled back to the same reservoir.
The level of control that it gives you with, regulating light, water, and we had more ideas, regulating airflow and all this stuff. But being able to control all those different elements really allows for more complex plants to grow. Basil's relatively easy; it doesn't need too much water and light. It's pretty survivable, but something like your orchid, where you need to give it a certain amount of lighting a day and very specific amounts of water, it can be optimized to grow something. Yeah, how's it going? So we basically, our inspiration was to reduce the amount of water used in industrial farming. So we created a system that can replicate, you could create a bunch of boxes and have more farms. And so our approach was using this aeroponic system. And so we have this demo just spraying on and off. This is how it's watering. Exactly, yeah. So from here, this lid flips up and the roots just dangle right into this area here.
Because it's
and so then we can read the humidity and how much water is flowing, depending on the plant that you're growing.
You realize a lot of the hard work is
and then all of the data sensing that we have is
so what are the sensors?
So the sensors we're using are in here. There's humidity and temperature sensors. So gauging how much, because this is really close, how much water is in the air. So then we also are reading the amount of water that's flowing through. So it's sensing the Hall effect sensor, just getting the rotations of our blade in there. And then we have a photoresistors and our temperature sensor on the surface of the box here. So then that's to regulate temperature and light.
Even this is spaced out too far.
So then all of
this is your sensor?
Yeah, the class actually provided this, and so in here there's.
You can even stack
it. You just have this little chip here. They actually communicate with CB radios. Yeah, exactly. So then you hear.
So I know.
So it's real nice to have this in a compact area that we just fit in on. That was one of the challenges, creating a design where this isn't going to be right next to the because other systems actually use humidity sensors are. They have special ones that
actually one of the biggest
soil. Absorb the soil, but since we kind of went with the aeroponic system, yeah, so we grew basil for the presentation essentially because it's really easy, it doesn't require too specific water or lighting. It would survive and look fine for the project, but ideally this. Yeah, hopefully. This isn't inside, so it's not even getting water right now. But ideally, no. So this is the only one actually. So for the 2 hours that we think that it'll be okay, maybe.
Is there a competition or something, or just algorithm class?
Just algorithm class. Yeah. It's Cyber-Physical Systems is the name. It's Cyber-Physical Systems. So, and it's a civil engineering class, which is a little bit uncommon for this type of class. And so what they really try to teach is how to incorporate it into industrial life. So for the farming, there's GE does something like this where they have large rooms grow these and grow optimal.
How about the lighting? Are you controlling?
Yeah, so this is just on a relay that's controlled with the PRD. Oh, it's here?
Wait, look. Wait, Grace, come here.
So yeah, so actually the lighting, it's just on and off. It's not intensity at all.
Oh, okay.
But we actually basically decided on, for depending on the plant, certain light hours.
Is it raining in there?
The hours that have to be. And so starting at the beginning of the day, turn it on in a shirt and then reading, okay,
Singles? They have singles?
Are we going to meet our goal of light intensity? So we just have the photoresistor sensing multiplied by the hours. So, oh yes, of course. This is kind of just more so dumb data, if you will, because it was we didn't have as much time as we had hoped. Yeah, exactly. So you have your flow rate to measure how much is coming through, but we estimate, a fraction of that's actually going to be absorbed. So there's water usage, energy usage here, light intensity. So our light is controlled actually on the catch-up-based system, so that if the estimated amount is less, then you turn on the light for the next 15-minute cycle. If it's more, you turn it off. If the expected is more than the estimated and the light is already on, or if the light is already off, then you have to say, okay, move to a darker area of the room. That's just all presented on our website. So. Yeah. Thanks for coming by. It's nice talking to you. Cleanup time?
Yeah. I'm gonna unplug on this.